Today, my team and I are going to be speaking about the green text menace that we all know and love. If you like blue text bubbles, turn this off now and go somewhere else. This isn't for you. We're going to be going over a good history of Android, the structures and architecture, privacy, Android versus iOS, the market share, and pros and cons. Android is based on a modified Linux kernel, and it was developed for mobile devices. That includes cell phones, tablets, mini little laptops, sometimes even. There are two primary variants. There's an open source project, which you can find on GitHub, or Android by Google, which, are on most of our phones, at least the more civilized people. Android is optimized for power consumption. And this right here is one of the primary reasons why it is the most popular mobile operating system worldwide. Android kernel is, again, based on a modified Linux kernel. It is based on the Linux kernel's long-term support branches. There are tons of modified Linux kernel versions out there for you to go and explore on GitHub. Now, the software includes libraries and APIs, which use C language, and it is also Java compatible. The open source nature of Android has led to massive support and application development by millions, if not billions, of developers worldwide. Android was founded in 2003. Later, it was acquired by Google in 2005. Google knew what they were doing. They were smart. Android originally started developing operating systems for digital cameras, taking pictures of all of the people's memories. They shifted focus to compete with Symbian and Windows mobile operating systems. They were originally pitched to Samsung and HTC. HTC was the first phone to run an Android operating system. It was the HTC Dream, also known as the T-Mobile G1. Reminds me of those little sidekicks. This phone was released in 2008.
In this section, I'll be covering the structures and the platform architecture of Android. And so we could see that it's basically a 6-layer architecture. And I'll start off with the Linux kernel, just give a brief overview. So the Linux kernel, we all know that the Android is based on Linux, and that just means that the Android has a Linux kernel. And, the main work of the kernel is to get work done from the hardware, like your camera or your Wi-Fi. And then so we have the libraries. And, we can have SQLite or OpenGL libraries or, libraries like C++ or Java libraries. And then you can have the application framework or the Java API framework. And these basically are for the purpose for the developer to make things easier or more understandable. And so maybe you have an activity manager or telephone manager, and I'll get into those later. But, let's say a manager, an activity manager wants to have the role of getting calls or sending SMS. And so telephone would be the telephony manager. And so as a developer, this helps, for the purpose that they don't need to go deep into the libraries or deep into the kernel, to do those things themselves. And then above that, we have the applications, and those are built into the phone, like your browser, your camera or applications and whatnot. And then we don't have it here, but there would be a layer for the user develop applications. And so getting to the more in depth on the Linux kernel. And so every kernel basically can have 3 main parts, and that is the device drivers, memory management, and the process management. And so the device driver gets the work from, the part of the kernel. And that's why we need the drivers. We need a driver for the camera. And so whose work would be, to take a picture, to turn a camera on, turn the camera off. And then we have the memory management, and its role would maybe you're trying to manage the entire memory, like through folders or where to be placed. And so that's all done by the memory management. Process management, if maybe you're playing music or doing some kind of operation, like you're trying to switch on your Bluetooth. And so these are all operations. And to get more on the hardware abstraction layer, that it basically allows the Android operating system to interact with the hardware, and it acts as a layer in between like a driver interface, and provides standard interfaces that expose device hardware capabilities to the Java API framework. And so the Java framework and hardware abstraction layers communicate with each other using binder interprocess communication. And I won't have time to get into it, but Android 8 and higher support the binderize and the pass-through hardware abstraction layers. And then we'll get into the native C and C++ libraries. This is where a lot of the performance comes from the phone. And so, libraries include, graphics and the SQLite, media codecs, and like browser engines. And so they're all part of the library layer. And, some are interfaces through Java, or some Java interaction, also, comes as a part of the Android library. And it's to make, it's simple, like some standard things that are, being followed, or some standard, procedures. And then we can have the Android application framework. And you can have basically an API interface, or activity manager, which we touched on earlier. And basically the activity managers manage the application lifecycle. So, you can have a activity manager where the developers trying to use managers to get the work done. And so, you have a telephony manager, which is pretty self-explanatory, but maybe you have a content manager provider, which, what would that do? Use them for SMS, or, an SMS inbox. And then we have the system apps, and this is at the user interface level, and apps such as Chrome and Facebook and Instagram. And at the user level, this is the biggest difference from iOS, as the user can customize almost everything, including the keyboard. Here's the software stack, and I'll just briefly, look at. So, you can have system apps like the email and calendar, and then you can have. And so then moving on to the Android runtime. We all know that about Java Virtual Machine. In a similar way, Android uses a DVM, and so it uses DEX files, and JVM uses jar files, and these DEX files are better for development because they are more compact and more efficient than class files, and they're more compact, so they give more improved battery power, and so that's why they use DEX files. And along with having core libraries like the Java standard library, collections, and input and output, and all these things form the Android runtime. And so, to sum it up in a good way, this is the DVM plus the libraries form the runtime. And some important aspects is the ahead of time and just in time compilation, and then it's also optimized garbage collection. And on Android 9 and higher, the conversion of the app packages DEX files to more compact machine code. And to conclude, I have a Poco F3, which uses MIUI, and that's based on the Android open source project. And so, and that serves as a basis for other operating systems created by Xiaomi, and like Poco and Pad and Watch or TV. And they all use MIUI, and I really like them because they allow the user to customize at the user level. You can customize a bunch of your apps. A lot of things you can't control at the kernel level, but there are some ways you can do it. Most of the time, if you're running on a greater version, then it's going to be kind of hard to do.
Hi, my name is Shalom Kompare, and in this part, we will talk about the privacy of Android. Let's begin with the user privacy. User can simply turn off all the connectivity they do not want. This can avoid hacking, for example. User can limit all activity that require data, for example, data that use Google or Chrome or any kind of sites. Users can lock their phone with personal identification. This is a good idea because it permits a layer of basic encryption of the device. For example, you can create a PIN number and use your birthday year to unlock your phone, or any kind of example like that. In addition to locking the phone, Android allows encrypting a device as well. What is encryption? Encryption is one of the best ways to keep your data private, whether your phone is hacking or stolen. The user can be wary of unknown sources by the fact that Android looks down the sources of software that can be used by only allowing you to download apps from approved sources that have been vetted by Android developers by default. Let's note that it is important that non-approved apps can be downloaded after changing some device setting, and it is not recommended at all. Google publishes monthly security updates that are separate from system updates. This permits them to avoid hackers by staying away of them as much as possible, and it also permits the improvement of performance and stability. It's permits to avoid problems by fixing bugs and errors. Let's talk about the security feature. AppSign allows developers to identify the information of the application, such as the creator, authentication to permit them to use fingerprint or camera ID, for example, to secure the device, encryption to secure the personal information, and we also have the trusted execution environment, as everybody knows TEE, that is a secure operating system. It guarantees code and data loads inside to be protected with respect to confidentiality and integrity. This permits to prevent unauthorized entity from outside. We have also the verified board to be sure that all executed code come from a secure and trusted sources. This is so helpful because it permits us to avoid virus on some application that is not recommended. We have also security around Linux that permits enforce mandatory access control over all processes without exception. And let's finish with the biometric that permits the authentication of the user. Thank you.
Hello everyone, I'm Brian Cavan, and this section is going to be Android versus Apple iOS. We chose Apple iOS because it's the most direct competitor to Android in the US and global markets. They were both launched around the same time frame. Apple was a year before Android was. They were both optimized for touchscreen interface. We see that the OS family of Android is Linux, whereas for Apple it was based off of Unix. For later models it was based off the OS X operating system. Their kernels are different. Android has a Linux kernel that's open source. Apple has a hybrid Linux structure, or kernel structure rather, sorry. Their file management systems are different. Android has a default Android file manager. There's other options available. Apple only comes with their Files app, and that's the only way to manage files on their system. Their virtual machines are different. And older Android has the Dalvik virtual machine, and newer Androids run Android Runtime, which replaced Dalvik VM and completely eliminated it. Apple doesn't have virtual machines, but they have virtual machine frameworks specific to each app type. So a camera app would use a camera virtual machine framework. A browser app would use a browser virtual machine framework, and each app uses those virtual machine frameworks at runtime. We're going to talk a little more about security later, but for the most part, Android is overall less secure. Machine and hardware level, Android can run on any processor. It was written to be run on any processor. There's maybe a handful of exceptions to that, but for the most part, if it's a processor, you can run Android on it. Apple can only run on ARM architecture. It was designed around ARM, and it's only made for ARM processors. Android applications are primarily written in Java, but you see C and C++ and a few other languages. You can actually write Android script in Python. Apple is primarily Swift and Objective-C. There's a few other languages, but you're mostly going to run into Swift or Objective-C. For memory management, Android has a built-in garbage collection on their virtual machine, and Apple moves garbage collection to each app. So each app is responsible for its own garbage collection rather than the entire OS itself. Looking at security, because there's a broader range of hardware available for Android, they are more at risk because there's more avenues of approach for that. Apple has much more proprietary hardware and consistency across hardware types, so there's less ways it can be hacked physically. Android does publish monthly updates, Apple doesn't, but they don't need to either. Because Android's open source, it also means people can get their hands on the code and find what makes it tick, whereas Apple is closed source, and it's much harder to crack into it. In theory, anyway. And because Android is the dominant mobile OS in the world market, which we'll look at here in a little bit, just numerically, it's going to be exposed to more attacks. However, if you make it an apples to apples comparison, pun fully intended, you'll see that Androids are still successfully attacked more frequently than Apple products are. From a user perspective, they're very different. Android is much more customizable. All the default apps are replaceable except a few key system apps like system settings, things like that. But virtually everything can be changed on an Android device. Their user interface is a little more complex because of that, but you can set it up exactly how you want. Apple has a much more simple and intuitive UI, and they built their whole brand around that. With Android, you can actually, it has root settings built into the device. You can go in and turn on in settings and do all kinds of developer stuff with it. With Apple, if you jailbreak it, you've just voided the warranty. Android is much more popular worldwide, so because of its low cost components or potential low cost. So from a user perspective, you're going to see more of those on a worldwide scale, whereas Apple is much more popular in the United States. Now we're going to look at market share. So worldwide, Android is the dominant operating system. It has about 2/3 of the global market for mobile operating systems. It blows the competition away, and its low cost or potential low cost is one of the key factors in that. Looking a little closer at the data, we see that it's 65.9% of the global market as of May of 2023. The low cost of components, again, makes it much easier as an entry-level phone. You can go to Walmart and get a track phone that runs Android for less than $100. iOS, on the other hand, has about 1/3 of the global market, and its higher cost and proprietary nature kind of limit its availability in a lot of areas. And we see that other mobile operating systems comprise less than 1% of the global OS market. Looking at the US side of things specifically, we see the same trend, but an inversion of the major two players. Apple's the dominant OS here in the United States, and Android takes a backseat to it. Looking a little closer at the data, we see that the numbers are almost exactly matched, with Android taking 1/3 of the US market and Apple taking 2/3 of the US market, and less than 1% going to other markets. In the United States, our good economy and Apple's brilliant marketing techniques have led to their success here.
The pros and cons of Android. Pros. It's customization. It's customizable. It's the most customizable operating system out there. Its open source nature allows it to do so. The hardware choice. The software is not bound to any specific piece of hardware, therefore it can be utilized on any hardware that would allow it to run. Its integration with Google services, such as Google Play Store and other things. This integration alone makes it one of the most superior, if not the most superior, operating system worldwide. Its multitasking and productivity capabilities. Cons. They don't really matter, but we'll go over them anyway. The fragmentation of user experience. Now, because of the customization ability, you will obviously have a fragmentation of user experience. Not everybody will experience this phone or this operating system in the same way, because we don't limit ourselves to a singular phone or a type of phone. Bring your phone as it is. We'll accept you. Security concerns. Since people have the capacity to modify and use whatever hardware they want on their phone, of course there's going to be security issues. Software is a crucial part in sealing security issues. But when hardware changes, it is difficult to always maintain a high level of security. Bloatware. But for real, this is probably one of the worst parts about an Android phone. iPhones, typically, they don't have all this junk when you go and buy a brand new iPhone. Maybe they do. I don't know. I only have an iPhone back in like 2008. But regardless, bloatware sucks. In conclusion, Android is the most popular operating system worldwide. While iOS does maintain a healthy lead in the United States, I think that's primarily due to its consumerism, elitist nature, which draws in crowds. Now, Android does have some security issues, but its structures and architecture are by far, in my opinion, superior. The flexibility, the customization, the ability to make it what it is, your own, that's what makes Android Android. Thank you.